let us learn about tangents. Okay, so what is a tangent to a circle? So a line which touches the circle at only one point is called a tangent to the circle. Fine. Suppose say this is the circle with center O. Okay. Now you can draw so many lines to this circle. Okay. Some lines they do not even intersect the circle. Okay. So there is no point of intersection. Some lines they cut the circle at 2 points. Okay. And there are some lines which just touch the circle at only 1 point. Okay. So except this point, no other point will intersect the circle. So I mean this line just touches the circle at only 1 point. So this line is called the tangent to the circle. Okay. And the point at which this tangent touches the circle is called the point of contact. Fine. So if a line touches the circle at only 1 point, it is called tangent, and the point at which the line touches the circle is called point of contact. So it is also said that circle touches this line, or you can say that line touches this circle. Okay. So if there is a word used touches the circle or touches the line, it means that line is tangent to the circle. Fine. So let us see one of the properties of tangent. Very basic but very important property. If P is the point of contact of tangent, then OP is perpendicular to the tangent. Fine. So what we have done is we have drawn a tangent to a circle and O is the center. So if we join this O and the point of contact, this will be perpendicular to the tangent. Fine. So this we need to prove it. So I mean, just try this for 2 minutes. Okay. Try to prove that these two lines are perpendicular. That is, say OB and say this is AB. So to prove that OP is perpendicular to AB. Okay. Yeah, try this for 2 minutes, then we'll discuss. Yeah, think about this. How will you prove it? So let us discuss why is it so. So what I'm doing is, let us take a point Q on this tangent which is not P. Okay. So take a point Q on the tangent different from P. Different from P. Okay. Now you can see that clearly Q lies outside the circle. Right? Because if Q was inside the circle, then this would not have been tangent, right? Because P and Q lies inside the tangent means this line would be something like this, and then this would not be tangent, right? So Q must lie outside the circle. So I'll just repeat it again. Had Q been inside the circle, and since P and Q are the points on this line, then if you join these 2 points, this won't be a tangent because it cuts the circle at 2 points. So Q has to be outside the circle. In fact, if you take any other point, any point on this tangent apart from P, all these points are outside the circle. Okay, fine. So since Q lies outside the circle, I can say that OQ is greater than R, where R is the radius of the circle. Okay. And since P is on the circle, I can say that OP is equal to R. So OP is equals to R and OQ is greater than R. Okay. So what I can see is that if you take any point on this line, okay, if you take any point on this line, that is definitely at a greater distance than point P from the center. So I can say that OQ is greater than OP for all points Q on the tangent except P. So this symbol is for all. I think we have already used it before. This is used as for all. Okay. So this means what? That OP is the shortest distance from O to the tangent. Okay. So this implies OP is shortest distance from O to the tangent. Okay. Because if you take any other point Q on the tangent, then this OQ is definitely greater than OP for any point. Okay. So OP is the shortest distance from point O to the tangent. And we have already studied earlier that from a point to a line, the shortest distance is nothing but the perpendicular one. Okay. So this perpendicular distance is the shortest one. Okay. We have studied already this because all these things are hypotenuse. So all these hypotenuse are definitely greater than this side. So since OP is the shortest distance from O to the tangent, this implies that OP is perpendicular to the tangent. Okay. So if you drop a perpendicular from the center onto the tangent, it will meet at point of contact. Or if you join the center and the point of contact, it will be perpendicular to the tangent. Fine. So just quickly note it down, then we'll move forward. So 30 seconds to note it down. Fine. So let us move forward. So tangent to a circle from an external point. Okay. So I mean, if there is a circle from an external point means what? The point that is outside the circle is called external point. So from an external point, you can always draw two tangents to a given circle, to any circle. Okay. So from an external point, you can always draw two tangents to a circle. Okay. So let us say PA and PB are the tangents from external point P. So A and B are what? The point of contacts here. So clearly OA will be perpendicular to the tangent and OB will also be perpendicular to the tangent. Fine. So this PA is called the length of the tangent and this PB is also called the length of the tangent. Okay. So this PA is the length of the tangent. So this is the length of tangent from P to the circle. From P to the circle. Fine. So from any external point you can draw two tangents and this is called the length of the tangent from point P to the circle. Okay. Yeah. Do this question. Okay, just a second. Just first note this one down. Just draw the diagram and just name the important points. No need to write the entire thing. Since I will send you the PDF, no need to write the entire thing. Just draw the diagram and just write the important points. Yes. So let us move forward. Yeah. Try this question. So try to read, understand, and draw the diagram. So if you get the answer, then let me know it in the chat. Yes, so most of you have done this. So there is a circle with center O. Okay. So from an external point, you have drawn a tangent to this circle. Okay. The radius of the circle is 5, and the distance of the point from the center, this is 13. Okay. And this is 5. This is the radius. And we know that this will be perpendicular to the tangent, right? And we want the length of the tangent. So what is length of tangent PA? It is nothing but square root of PO square minus AO square. So it is 13 square minus 5 square, which is 12. Fine. So the length of the tangent is 12. So 10 seconds to note it down. Yes, let us move forward. So let us deeply study what happens when we draw two tangents from an external point to a given circle. Okay, so this is the given circle with center O. Fine. So from an external point P, we have drawn two tangents, that is P and PB. Okay, so now OA is equals to OB, right? Because OA is radius and OB is radius, so OA is equals to OB, and OA is perpendicular to PA and OB is perpendicular to PB because of the first property which we have studied for tangents, that line drawn from center to point of contact is perpendicular to the tangent. Okay, now what I'm doing is I'm joining this PO. Fine. So I have drawn two tangents first from an external point, and I have joined this radius. Okay, and next I have joined this PO. Now if you see these two triangles, that is the triangle POA and the triangle POB, you can see that these two triangles are congruent because right angle hypotenuse is common side and OA is equals to OB. So triangle PAO is congruent to triangle PBO by RHS. Okay, so by RHS, these two are congruent. So if these two are congruent, then I can say that PA must be equal to PB, right? So PA must be equal to PB. Okay, it means what? the length of tangents from an external point are equal. So from P, if you draw two tangents, then they will be of equal lengths. That is, PA would be equal to PB. Also notice that these two angles would be equal, right? Because these two are congruent triangles. So I can say that angle APO should be equal to angle OPB, because these two are congruent triangles. And of course, these two angles will also be equal. Okay. So next, let us observe that this quadrilateral PAOB, this is a kite, right? Because OA is equals to OB and PA is equals to PB. Fine. So both the pairs of adjacent sides are equal. So this quadrilateral PAOB is what? It is a kite. Fine. Because both the pairs of adjacent sides are equal. So this quadrilateral PAOB is a kite. Next. So since this OA is perpendicular to PA, okay, since this is perpendicular, so this is a right angle triangle, right? So if I draw a circle with PO as diameter, okay, so it should definitely pass through point A, because angle in a semicircle is how much? 90 degrees. So if I draw a circle with PO as diameter, right? If I draw a circle with PO as diameter, then every point, this PO will subtend 90 degrees at every point, right, on the circumference. And since angle PAO is also 90 degrees, it means what? If I draw a circle with PO as diameter, it should pass through point A. And similarly, if I draw a circle with PO as diameter, it should also pass through point B, because angle PBO is also 90 degrees. So circle with PO as diameter passes through both A and B, okay, because this is 90 and this is 90. So if I draw a circle with PO as diameter, then definitely it will pass through points A and point B. So I can say that A, P, B and O are concyclic because they lie on the same circle, right? So PAOB is the cyclic quadrilateral because P, A, O and B all lie on a same circle, and that circle is the circle with PO as diameter. Okay, that circle is the circle with PO as diameter. So this is a cyclic quadrilateral. And also you can see that the opposite angle, the sum of opposite angles, that is angle A plus angle B, is 180. So angle P plus angle O will also be 180 degrees. Fine. So since this PAOB is a kite, because both the pairs of adjacent sides are equal, and in a kite we know that the diagonals are perpendicular, right? And also we know that in a kite the longer diagonal bisects the shorter diagonal. So here AB is the shorter diagonal of this kite, PO is the longer diagonal of this kite. So the longer diagonal bisects the shorter diagonal, that is AC is equals to CB. Okay, these two lengths are equal. Fine. We have already done this in the properties of kite. I have also told you to prove all the properties of kite, rhombus, trapezium and all the quadrilaterals. So if you haven't proved at that time, so prove it today after the class. Okay. So those properties are very important. So the longer diagonal in the kite will bisect the shorter diagonal. You can prove it simply using the congruencies of triangle. Fine. Yes. So OP is nothing but the perpendicular bisector of AB, because the longer diagonal bisects the shorter diagonal. So AC is equals to CB and OP is perpendicular to AB. Fine. So let us just once again discuss what we have done. So there was a circle initially. Fine. This was the center. From an external point P, we have drawn two tangents and the point of contacts are A and B. So since OA is equals to OB and these two are perpendicular, then we proved that triangle PAO is congruent to triangle PBO. And since these two triangles are congruent, then I can say that PA is equals to PB. So this quadrilateral PAOB was our kite and it was cyclic. And if I draw a circle with PO as diameter, it will pass through A and B. Okay. So this is what we have discussed. It is pretty important. So just note it down clearly. Okay, note all the points clearly. So I'm giving you 1.5 minutes to note it down. Okay, so let us move forward. So tangents to a circle at the endpoints of diameter are parallel. Okay, if O is the center and AB is the diameter, then if I draw the tangents at point A and point B, okay. By the way, we have studied what is a tangent from external point to a circle. What do we mean by tangent at a point on a circle? Okay, suppose P is on the circle, then what do we mean by tangent at point P? Fine. Tangent at point P is nothing but this tangent. Okay, that such that the point of contact of the tangent is P. Fine. So tangent at any point on the circle means what? A tangent such that the point of contact is that point P. Okay. So this is the tangent at P. This is the tangent from P. Okay. This is the tangent from P and this is the tangent at P. So if I draw the tangents at the endpoints of diameter, then those two tangents will be parallel. Fine. Let us move forward. Yeah, do this question. Draw the diagram and think about it. So if you get the answer, then let me know it in the chat. Fine. So let us discuss this one. Already some of you have solved, but all of you have got the wrong answer for AB. Let us see. So there is a point P. This is the center. Tangents are drawn from P to a circle with center O of radius 7 centimeters. OP is equals to 25. Fine. Point of contacts are A and B. So say this is a tangent. So this is A. And say this is a tangent. So this is B. So OA is perpendicular and OB is also perpendicular, and these are 7 because it is the radius. And OP is given to us as 25. So clearly PA is equals to PB is equals to square root of 25 square minus 7 square, which is 24, right? So this side length you will get as 24 from the Pythagoras theorem. Now area of quadrilateral OAPB. How do we find the area of quadrilateral OAPB? Okay, so I mean, we don't know any direct formula. I mean, we can use half product of diagonals, but we don't know the length of AB. So let us do one thing. Let us break it into triangles. So I will find the area of triangle POA plus area of triangle POB. And the area of triangles is pretty easy to find because that is half base times height. So since this is a right angle triangle, the base is 24 and the height is 7. I mean, you can take reverse way. Base is 7 and height is 24. So this is area of triangle APO plus area of triangle BPO. So both are equal. So that is twice of half of 7 into 24. So that you will get as 168. Okay, fine. So now the challenge is how to find this length AB. How to find this length AB. That is the challenge. So I mean, it is also not very difficult. So what we'll do is we'll find area in another way. So area I can write it as area of APO plus area of BPO, but area of APO is half times OP times, say this is perpendicular, right? Because in a kite diagonals are perpendicular. So if I take the base as OP, then height will be AC. So area of triangle APO is half times OP times AC. So half OP into AC. So which is equal to half of 168, right? Because these two triangles are congruent. So then I can just cancel this, and OP is 25. So I'll get AC is 168 over 25. So that implies AB is nothing but 2 into 168 by 25. Fine. So because the shorter diagonal is bisected by the longer diagonal, so AC is equals to CB. So AB is nothing but twice of AC. Okay. So it is twice of 168 by 25. So this will be the value of AB. Also, you can use that the area of entire quadrilateral is half product of diagonals. So half into OP into AB is 168. So again, you will get AB as twice of 168 over 25. So just copy it down, then we'll move forward. Yes, so let us move forward. So we have studied some of the properties of tangent from an external point. So let us discuss what is alternate segment theorem. Okay, it is very important theorem. So you should know it very well. So let us say there is a circle. Okay, there is a circle, and there is a tangent at there is a tangent to a circle and the point of contact is A. Okay. So now you are drawing a chord to the circle through A. Okay. So this AB is the chord to the circle through A, right? Now the angle which this chord makes with the tangent, okay, the angle which this chord AB makes with the tangent, that is this angle, this one. Okay. So the angle which the chord makes with the tangent is equal to the angle made by this chord in the alternate segment, that is this segment. Okay. So I mean, the chord AB divides the entire circle into two segments, right? This one is the minor segment and this one is the major segment. Okay. So if AB is the chord, then let us say it makes an angle alpha with the tangent. So then this chord will also make angle alpha in the alternate segment. So this angle will be alpha, this angle will be alpha. Okay. And similarly, if this chord makes this angle with the tangent, then this angle will be the angle that this chord makes in the alternate segment. So now this is the alternate segment. So angle BDA will be equal to this angle. Okay. And angle BAT will be equal to this angle. Fine. So if from point of contact, POC is nothing but point of contact of tangent, a chord is drawn, this is the chord, then the angles which the chord makes with the tangent line are equal respectively to the angle formed in corresponding alternate segment. So this angle is equal to this angle and this angle is equal to this angle. Okay. So angle BAT is equals to angle BCA. So this one is this one. And angle BAP, that is this angle, let me so say this angle is equal to this angle. Okay. So angle BAP is equals to angle PDA. So this is the alternate segment theorem. So what is the requirement in the alternate segment theorem? That there must be a tangent to a circle and the chord must be through the point of contact. Okay. So there is a tangent and the chord must be through the point of contact. So the angle which this chord will make with the tangent will be equal to the angle made by the chord in the corresponding alternate segment. So let us prove this one. Okay, let us prove it. Okay, so let us take a circle. So this is the tangent and this is the point of contact, that is A. Okay, so this is the chord. Say this is angle. Okay, so this is PT, right? So this is P and this is P, this is B, this is C. Okay, so you need to prove that angle BAT is equals to angle BCA. Okay, this is what you need to prove. So just try this for a minute, then we'll discuss. Try to think about this. How will you prove this? So let me give you a hint. What you do is you take the center of the circle and from that center you join the point of contact, that is OA. Okay. So take the center as O and join OA. And then you think about this. So let us discuss about this. So say O is the center and let us join OA. Okay. So join OA. Okay. And then what I can say is that angle OAT is equals to 90 degrees, right? This entire angle will be 90 degrees because the line joining from the center to the point of contact is always perpendicular to the tangent. So this implies that angle OAB is equals to 90 degrees minus angle BAT. Okay, so this angle is 90 minus this one. So let us join OB also. Okay, now in triangle OAB, OA is equals to OB is equals to radius, right? So this implies angle OBA is equals to angle OAB. That is equals to 90 degrees minus angle BAT. Fine. So this angle is 90 minus, let us say this is theta, then this is 90 minus theta. This is also 90 minus theta. That is what we have done. So this is theta, this is 90 minus theta, and this is 90 minus theta. Okay. So this implies that angle AOB is 2 theta, because in triangle OBA, sum of all the angles should be 180, right? So angle OAB is nothing but twice of angle BAT. Okay. So now the chord AB subtends 2 theta at the center. So at the circumference, it will subtend theta, right? So then if this is 2 theta, then this is theta. So this implies angle ACB is equals to half of angle AOB, which is equal to angle BAT. So angle ACB is nothing but angle BAT. Fine. So this is the proof of alternate segment theorem. So if there is a tangent to a circle, and if you draw the chord through that point, then the angle which this chord makes with the tangent is equal to the angle made by this chord in the corresponding alternate segment. Fine. Similarly, this angle will be equal to this one. Okay, these two angles will be equal. Fine. So just copy it down quickly. We'll move forward. Yes, so let us move forward. So intersecting chords theorem. What is intersecting chords theorem is, if two chords AB and CD in a circle intersect at point P, okay, so if two chords AB and CD in a circle intersect at point P, then PA into PB is equals to PC into PD. Okay, so PA times PB is PC times PD. So just try to prove this. Okay, try to prove this. Think for a minute. I think we have discussed a similar problem yesterday, and I have also told you an important idea in that problem. Yes, so let us discuss. So what I'm doing is I'm joining this BC and AD. Okay, so join AD and BC. Now these two angles are equal because these are vertically opposite angles. Angle ADC is equal, just a second, not angle ADC. Angle APD is equals to angle CPB because these are vertically opposite angles, and these two angles are equal, right? Because these are the angles subtended by same arc AC. So this angle is equal to this angle, right? So angle ADC is equals to angle ABC because these are angles in same segment. Same segment. Okay. Similarly, you can say that angle DAB is equals to angle DCB. These are also the angles in same segment. That is, this angle is equals to this angle because this arc subtends this one, and this arc also subtends this angle. So these two are equal. So this implies that triangle ADP is similar to the triangle BPC. Okay, these two triangles are similar, this one and this one. So this implies that the sides are proportional. Sides are proportional. So let us write PA over. So PA is the side opposite to this one. So the side opposite to the same angle is PC is equals to PD over PB. Okay. So PD is the side opposite to this angle, and the side opposite to same angle in this triangle is PB. So this simply implies that PA into PB is equals to PC into PD. So this is called the intersecting chords theorem. So just note it down quickly, then we'll move forward. Fine. So let us move forward. So another theorem, it is also an important one. If PB is a secant to a circle which intersects the circle in A and B, okay, and PT is the tangent, okay, so PT square is equals to PA into PB. This is clear. PT square is PA times PB if PB is the secant and this is the tangent. So PA times PB is PT square. So let us try to prove it. So first, I will prove this using the similarity of triangles. So let me, try to bring the sides into proportion. So what I have to prove is that I have to prove that PA over PT is PT over PB. Fine. So I have converted this one into this step. So basically, I need to prove that these two triangles are similar, triangle PAT and triangle PBT. Right? If these two triangles are similar, then I can prove this because the sides are proportional. So let us join this AT. So join AT. Fine. Also, let us join BT. So join AT and BT. Fine. So now this AT is the chord and T is the point of contact, right? This is the tangent and this is the chord through the point of contact. So this angle will be equal to this angle by the alternate segment theorem, isn't it? If PT is the tangent and AT is the chord through the point of contact, then the angle made by the chord and tangent is equal to angle subtended by this chord in alternate segment. So angle ATP is equals to angle ABT. This is by alternate segment theorem. Okay, and angle BPT is equals to angle BPT because this is common to both the triangles. So basically this angle is equals to this angle and this one is common. So I can say that in triangle PAT I have two angles, and in triangle PBT also there are two angles. So these are equal. So basically by the AA axiom I can say that triangle PAT is similar to triangle PBT by AA axiom. Okay, angle. So this implies that the corresponding sides will be proportional. So let us write PA. PA is what? In this triangle PAT, opposite to this angle, the side is PA. So what is the side opposite to the same angle in this triangle? It is PT. So PA over PT is equals to the side opposite to this one, this angle. This is PT, and the side opposite to this angle is PB, is equals to PT over PP. Okay. So then we have 2. Is it fine? So I mean, since two angles are equal, then the triangles are similar, right? So this will also implies that angle PAT is equals to angle BTP. That is, this angle is equal to this angle, right? Because in these two triangles, in triangle PBT and PAT, two angles are equal. So third angle will also be equal. Okay. So this angle will be equal to this angle. So you can write that sides are proportional. Fine. So if there is a secant and it cuts the circle at 2 points A and B, and PT is the tangent to the circle from point B, then I can say that PA into PB is PT square. So just quickly copy it down, then we'll move forward. Yes, so let us move forward. Yeah, do this question. Very simple question on the direct formula. PT is the tangent here, okay? PT is the tangent and PB is the secant. So if you get the answer, then let me know it in the chat. So directly you need to put the values in the formula. PA into PB is equals to PT square. So PA into PB is nothing but PT square. So PA, let us say PA is equal to X. Okay. So this implies that let PA is X. So this implies that PA is x into PB is x plus 3. This is equal to PT square, that is 36. So this implies x square plus 3x minus 36 is equals to 0. So you need to solve this quadratic. I mean, if you know the direct formula to solve the quadratic, then you can do so, because this quadratic, I don't think you can factorize it. 36. Yeah, you can't factorize this. So you just directly use the formula. X is equals to minus 3 plus root over 3 square plus 4 into 36 by 4. So this is the value of x. Fine. Then if you get the value of x, that is PA. So you can find the length of PB. PB is x plus 3. Okay. So when some of you do this mistake that you write PA into AB as PT square. Okay. I think some of you have done that. PA into AB, you have written it as 36, and PA you have got it as 12. So this is mistake. Okay. This is mistake. Don't use PA into AB as PT square. It is PA into PB is PT square. So use the correct formula. This is correct formula. Fine. So let us move forward. Now let us say from an external point P, you are drawing two secants to a circle. Okay. So one secant is cutting the circle at points A and B, and the other secant is cutting the circle at points C and D. So then I can say that PA into PB is PC into PD. So try to prove this one. It's pretty straightforward. Just try to prove this. Try to prove this. So I mean, it is pretty straightforward, nothing much to think about here. So let us just draw a tangent from P to the circle. Okay. So draw tangent from P to the circle. So let the point of contact be T. Okay. So the point of contact is T. So we know that PA into PB is PT square. Also, we can say that PC into PD is PT square, right? Because this is a secant which cuts the circle at 2 points C and D. So PC times PD is also PT square, and PA times PB is also PT square. So then simply I can say that PA times PB is equals to PC times PD. Okay. PA times PB is equals to PC times PD. Fine. Also, I mean, you can prove it without drawing the tangent. So you have to, I mean, I think you have to prove that these two triangles are similar. That is, triangle PCD is similar to triangle PAD. That you can do because these two angles are equal, right? The CA only subtends these two angles. So these two angles are equal and this is the common angle. So I can say that this triangle PAD is similar to triangle PCB, then you can just do that, the sides are proportional, and you'll get PA into PB is PC into PD without drawing this tangent. Okay, if you draw the tangent, I mean, it's directly visible. Fine, so we'll end this session here and I'll send you the assignment in the group. And if you have any queries, then you can message me.